Example 1, write an equation of a line that passes through 5, negative 4 and is parallel to the line y equals 2x plus 3. So if two lines are parallel, we know that the lines don't intersect and also they have the same slope. So what we need to do is find the slope of parallel line. Well, the given equation here has a slope of 2. Remember, the slope is the number that gets multiplied to the variable x. And it has a y-intercept of 3. The new equation is going to have the same slope as the original equation here. So the slope of the new equation should be 2. So the parallel line that passes through 5, negative 4 also has a slope of 2. So the only difference between the new line and this original line is the y-intercept, where they cross the y-axis. So what we're going to do is we're going to use the point slope formula to figure out what the b value is, which is the y-intercept. So in here, we know that y1 is going to be the y value here, which is negative 4. x1 is going to be the x value. So my x value is going to be 5, and then the y1 is going to be negative 4. And again, right here, when you have a minus and a negative number, when those two minuses face each other, that turns into a plus. So y minus negative 4 is the same thing as y plus 4. And then over here, we can distribute the 2. 2 times x is 2x, and 2 times negative 5 is negative 10. Now to find the equation, we just need to isolate the variable y. So let's subtract 4 on both sides. You get y equals 2x minus 14. So the two lines, which is the original equation here, and this equation are parallel lines. They both have the same slope, but they have different y-intercept. Now let's look at example 2, which is very similar to that. We want to find an equation that passes through this different point, but is parallel to the line y equals 3x plus 2. And again, let's find the slope of a parallel line. Well, the given equation has a slope of 3. So the parallel line that passes through the point negative 1, 4 should also have a slope of 3. Use the point slope formula. Slope is going to be 3. x1, right, my x value here is negative 1. And then y1 is going to be 4. Now in this case, we have y minus 4 is equal to, again, a minus and a negative face each other, so that turns into a plus. So 3 times x is 3x, and 3 times 1 is positive 3. To isolate the variable y, we add 4 on both ends. You get y equals 3x plus 7. So the equation in slope-intercept format would be y equals 3x plus 7. Example 3. Determine the equation of a line that is parallel to the line through the points 3, 2 and negative 3, negative 1 and passes through the point 4, negative 2. So the new equation goes through this point and is parallel to the line that goes through this point and this point. So first thing we have to do is find the slope of the original line, which goes through the point 3, 2 and negative 3, negative 1. Using the point slope formula, difference in y over difference in x, that is negative 1 minus 2 divided by negative 3 minus 3 gives you that negative 3 over negative 6. And that simplifies into a positive 1/2. So that means the original line has a slope of 1/2. Now the equation that is parallel to that should have the same slope. Now what we have to do is we have to use the point slope formula to find the equation using the point 4, negative 2 because the new equation goes through that point. So that means this is my x1, y1 in this case. So if I substitute the values, my y value is negative 2, my x value is 4, and then the slope is what I have here. And again, two negatives make positive, so that becomes a y plus 2 here equals half times x minus 4. Distribute the 1/2 here to get this. And the last step would be to subtract 2 on both ends to isolate the variable y. So y equals, in this case, 1/2 x minus 4. So if two equations have the same slope, they are parallel to one another. That means they don't intersect, but they have different y-intercept. The other type of line that we have is perpendicular lines. Now, perpendicular lines do intersect, and at the point of intersection, they make a 90 degree, which is a right angle. So, two lines in the same plane that intersect to form a right angle are called a perpendicular lines. So, non-vertical lines are perpendicular if and only if their slopes are negative reciprocal. So the slope of the two lines would be the negative reciprocal of one another. Or you can think of it as the product of those two slopes is always equal to -1. So vertical lines are perpendicular to horizontal lines. All right, in this equation, we're trying to find an equation that passes through the point -3, 1 and is also perpendicular to the line y equals 1/2 x plus 3. So this original equation here has a slope of 1/2 and a y-intercept of 3. And slope is all we need here. So if the slope here is 1/2, the perpendicular slope should be the negative reciprocal of this. Well, the reciprocal of this would be 2/1. And 2/1 is the same thing as 2, but of course the sign should be the opposite of this. So that means the slope that is perpendicular to the line that goes through this is going to be -2. And again, you swap the numbers here, the 1/2 becomes 2/1, and 2/1 is nothing but +2. And then it should be the opposite of this sign. So if this is positive, the perpendicular should be a negative, and vice versa. Now, once you have the slope, we know the point that it goes through. So we can use the point slope formula, which we know that x value, or the x1, is -3. And we have the y value, or the y1, is +1 from this point here. And then we know the slope is -2. And then the rest is just simplify this. On the left-hand side, we end up with y minus 1. And then over here, this negative and negative becomes positive. And then we just need to distribute the -2. And then finally, just add 1 to both sides. You get -2x minus 5. Because -6 plus 1 is -5. So this equation here and this equation, they should both be perpendicular. That is, if I were to graph those, they should intersect. And of course, at that intersection point, they make a 90 degree. Or the product of this number and this number, that is, when you multiply those two numbers, it should always be equal to -1 as long as you're dealing with perpendicular lines. Example 5 is to write the equation of a line that passes through this and is perpendicular to this, which is very similar to example 4. So first, determine the slope of the original. Well, the slope of the original, as you can see here, is +3. Well, what would be the slope of the perpendicular line? Well, if a line is perpendicular to this, then it's going to be the opposite sign. So it's going to be a negative. And then, of course, the reciprocal of this. Well, 3 could be written as 3/1. If you swap the numbers, you get 1/3. So it's -1/3 would be the new slope. Now, according to the point slope formula, substitute the values, distribute the -1/3. That is -1/3 times x gives you this. -1/3 times -4 gives you the +4/3. And then add 3 to both ends. you get y equals negative 1/3 x plus 13/3. Again, if you take your slope here, you multiply it to the slope right here, 3 times negative 1/3 should be negative 1. Example 6, find an equation of a line that contains the point 4 comma negative 2 and is perpendicular to the line x plus 3y equals 6. Now, the equation of the line here is not written in the slope-intercept format, that is the y equals mx plus b. So, first thing we have to do is convert that into y equals mx plus b. That is, isolate the variable y first and figure out the slope from that. So to do that, we're going to bring this down. Let's isolate the variable y. So at first, let's remove the x by subtracting. And then we're going to divide every term by 3, so you get this right here. Now the negative 1/3 is coming from here. When you divide this by 3, you get negative x over 3, which is the same thing as negative 1/3 x, and then plus 6 divided by 2. 6 divided by 3 is 2. So from here, we can see that the slope of the line, or the original line, is negative 1/3. Any line that is perpendicular to this line has a slope of 3. Now the reason is that because if two lines are perpendicular, their slopes should be the negative reciprocal. Well, the negative of this would be positive. The reciprocal of this number is 3 over 1, which simplifies into 3. That's how you get the positive 3. Now, because the point 4 comma negative 2 is on the line with the slope of 3, we use the point slope formula, which is y minus y1 equals this. Now, substitute the values. We have our x1, our y1, and then of course the slope is 3 because we're finding the perpendicular line. So if I plug them in, this is what I get. Again, negative and negative makes positive, so you get a y plus 2 on the left-hand side. And of course, on this end, if you distribute the 3 times x is 3x, and 3 times negative 4 is negative 12. Isolate the variable y by subtracting 2 on both ends. You get y equals 3x minus 14. This next example here is very similar to one of the parallel lines that we did. Example 6, find an equation of a line that contains the point 4 comma negative 2 and is perpendicular to the line x plus 3y equals 6. Now, the equation of the line here is not written in the slope-intercept format, that is the y equals mx plus b. So, first thing we have to do is convert that into y equals mx plus b. That is, isolate the variable y first and figure out the slope from that. So to do that, we're going to bring this down. Let's isolate the variable y. So at first, let's remove the x by subtracting. And then we're going to divide every term by 3, so you get this right here. Now the negative 1/3 is coming from here. When you divide this by 3, you get negative x over 3, which is the same thing as negative 1/3 x, and then plus 6 divided by 2. 6 divided by 3 is 2. So from here, we can see that the slope of the line, or the original line, is negative 1/3. Any line that is perpendicular to this line has a slope of 3. Now the reason is that because if two lines are perpendicular, their slopes should be the negative reciprocal. Well, the negative of this would be positive. The reciprocal of this number is 3 over 1, which simplifies into 3. That's how you get the positive 3. Now, because the point 4 comma negative 2 is on the line with the slope of 3, we use the point slope formula, which is y minus y1 equals this. Now, substitute the values. We have our x1, our y1, and then of course the slope is 3 because we're finding the perpendicular line. So if I plug them in, this is what I get. Again, negative and negative makes positive, so you get a y plus 2 on the left-hand side, and of course on this end, if you distribute the 3 times x is 3x, and 3 times negative 4 is negative 12. Isolate the variable y by subtracting 2 on both ends. You get y equals 3x minus 14. This next example here is very similar to one of the parallel lines that we did. All right, here's our next example. Find an equation of a line that is perpendicular to the line through the points negative 2 comma 4 and 4 comma negative 6 and passes through the point of 2 comma negative 1. So in this problem, we're trying to find an equation that is perpendicular to the line that goes through the 2 points here, meaning the original slope could be found using those 2 points here. So let's go ahead and find the original slope using the 2 points here. Label your points as x1, y1, x2, y2, and then use the slope formula. Difference in y over difference in x simplifies into this, which is equal to this right here. So the original line is going to have a slope of negative 5/3. The perpendicular slope, swap the numbers and make this positive. Right? It's the negative reciprocal of those numbers. So that would be 3/5 in this case. Now the perpendicular slope would be this, and we know the line goes through this point. So using those two and the point slope formula, we can figure out the new equation. Plug them in, you get y minus negative 1 equals 3/5 times this. Negative and negative makes positive. If I distribute this 3/5, 3/5 times x is 3/5 x, and 3/5 times negative 2 is a negative 6/5. To finish the problem, subtract 1 on both ends, and you get y equals 3/5 x minus 11/5. For this example, we're being asked to find an equation that is perpendicular to the line that we're given and passes through the point 2 comma 1. So perpendicular means they're going to have a slope that are negative reciprocal to one another. So first thing that we have to do in this case is find the slope of this line using that rise over run. Well, in order to do that, I need to come up with 2 points, and we're going to use this point here and this point here. So slope is the same thing as rise over run. That is, from the lower point, how much do you need to rise and how much do you need to run over to get to that other point? So from here, my rise would be, I'm rising up 1, right? From here to here is a distance of 1. So since you're going up, that's a positive 1. Now your run is from here all the way to here, which is the same as the distance from here all the way to that origin point, which is your x and y is 0. So from 0 to negative 0.5, that's a distance of 5. And because you're running to the right, it should be positive 0.5. Now, dividing those two numbers will give you a value of 2. So that means the slope of this line is going to be positive 2. Now, perpendicular slope is going to have the opposite sign. It's going to be a negative number. And then, of course, the reciprocal of this number. Well, 2 could be written as 2 over 1 as a fraction. And then when you swap the numbers, it becomes 1/2. So it's going to be a negative 1/2. So an equation that is perpendicular to this will have a slope of negative 1/2. Now let's use the point slope formula and substitute the values that we know. We know that the perpendicular slope is negative 1/2, that's my m, and since the line goes through this point, my x1 is going to be replaced by 2, and the y1 would be replaced by 1, and that's what the equation looks like. From here, we can distribute this negative 1/2. Negative 1/2 times x gives you a negative 1/2 x, and negative 1/2 times negative 2 is a positive 1. To solve for x, we just add 1 on both ends. You get y equals 1/2 x plus 2. Thank you.